Hello, today we're going to take a look at solving equations. So please write down the following title. And we're going to talk about the 3 essential rules of math. So rule number 1 says that we can do anything we want to an equation as long as we do it to both sides. Rule number 2 says that when we're working with addition and subtraction, we can change an expression by using a zero, or we can solve equations by making a zero. And rule number 3 says that when working with any other function, such as multiplication or division, we can change expressions by making a 1, or we can solve equations by making a 1. So when we're looking at solving this one-step equations today, we're going to look at and we're going to explore these 3 rules, essential rules of mathematics. So we're going to see how these rules come into play with a series of examples. So the first thing that we're going to look at is some examples involving addition and subtraction. And I know that when we're first starting out, especially with these one-step equations, you may be able to do these in your head. However, I really want you to focus on writing these solutions to these problems using proper mathematical format so that when we get to those more complicated questions, you're going to understand what to do, and it's going to be easier for you to write your solutions and to articulate your thinking in that manner. So when we're involving questions that involve addition and subtraction, what we need to do is we need to either add or subtract the same number from each side of the equation. So what that means is that we're going to add or subtract the same number from either the left side of the equal sign or the right side of the equal sign, so that we can keep that equation balanced. And this essentially is what we talk about when we talk about making a zero. When we started to look at algebra and we looked at algebra tiles, we talked about the fact that if we have the same algebraic expression, or we have the same term, and one is positive and one is negative, they cancel each other out to make zero. So we're going to follow that same sort of principle when we're looking at questions involving addition and subtraction when we're solving equations. So let's take a look at two examples. So for example, if I have x plus 2 is equal to negative 3. Well, the first thing that I want to do is I want to start by making a zero. So the goal for solving equations is to figure out the number for x that makes that statement true. Another thing that you can think about when you're solving for equations is to isolate the x. So we want to get the variable all by itself. And the way that we do that is we have to look at what's being added or subtracted to that variable term. And so right now we are adding 2 to x. So in order to make that 0, I have to do the opposite of adding 2, which is subtracting 2. So I'm going to subtract 2 from both sides. I'm going to subtract 2 from the left-hand side, and I'm going to subtract 2 from the right-hand side. This makes that 0 on the left-hand side. So 2 minus 2 is 0. So we're making that 0. So what I have left is the x on the left-hand side, and negative 3 take away 2 is negative 5. So we're thinking about those rules that we looked at when we added and subtracted positive and negative integers. If we take a look at another example that involves subtraction first, if I have x minus 3 is equal to 5, again, I want to think about what is on the same side as the variable. So right now I have a negative 3 or subtracting 3. I have to do the opposite of subtracting 3, which is adding 3 to both sides. That makes the 0 on the left-hand side. Negative 3 plus 3 is 0. So what I end up with is an x on the left-hand side, and 5 plus 3 is 8. The next thing that we're going to look at in terms of some solving one-step equations is what we do when we multiply or divide. So what we have to do for this one is we are either multiplying or dividing both sides of the on either side of the equal sign by the same number. And this is essentially what we're doing when we're thinking about making a 1. So again, we'll do a couple of examples. So if I start with, let's say, 2.5. So 2.5x equals 5. What I want to do is I want to think about, well, what is that operation that's happening between my 2.5 and my x? That's multiplication. So the opposite of multiplication is division. So I want to divide both sides by the coefficient that's in front of the variable. So I'm going to divide the left-hand side by 2.5, and I'm going to divide the right-hand side by 2.5. What this does is it creates a 1 on the left-hand side. 2.5 divided by 2.5 is 1. So that's how we made that 1. So what we're left with is an x on the left-hand side. And if I use my calculator to do 5 divided by 2.5, I get the answer of 2. And I've purposely used that a decimal number here so that we couldn't, it's not as easy to do it in our head as possible. Okay, but let's take a look at another example. Let's pretend that I have x divided by -3 is equal to -9. So the operation that's happening when we're dealing with a fraction is division. So the opposite of dividing by a number is multiplying by a number. So I need to multiply both sides of my equal sign by -3. So I'm multiplying the left-hand side by -3, and I'm multiplying the right-hand side by -3. Again, this creates that 1 on the left-hand side. I have the -3 on the top of the fraction, and I have a -3 on the bottom of a fraction. Remember that you can turn anything into a fraction by putting it over 1. And I could just, again, multiply my numerators to give me -3x, and 1 times -3, so multiply my denominators, also gives me -3x. So I can think about that in terms of coming up with my 1. Maybe it's a little bit easier to see my 1 now. If I have the same number on the top and the bottom of a fraction, it reduces down to 1. So I have 1x is equal, or just x, -9 times -3. Two negatives multiplied together give us a positive value, and 9 times 3 is 27. So the value of this equation, or the value of x for this equation, is 27. You're going to practice some of these solving one-step equations in a group project or in a group assignment. So you're going to be taking a look at a logic puzzle today in groups of 3. You're going to each be responsible for solving your own worksheet, and then you're going to work together in your group of 3 to solve the logic puzzle. We've done something like this before, so we're just applying it now to solving one-step equations. So remember, and maybe it's helpful to maybe just do a couple of more examples before you get started, to think about those opposite operations. So when we're thinking about opposite operations, we are thinking about those mathematical operations that are opposite each other. And so a more formal definition of opposite operations, or even inverse operations, is that two operations are inverses of one another if they undo each other. So addition is the opposite of subtraction, and multiplication is the opposite of division. So if it's helpful to do a couple more examples, then we'll keep watching this video. So if we have this next example, so example number, I guess this would be example number 5. If we have x plus 7 is equal to 5, we're doing the opposite of adding 7, which is subtracting 7. We're going to subtract 7 from both sides. That makes our 0 term. 7 take away 0, or 7 take away 7 is 0. We have to remember to subtract 7 from both sides. So what we're left with is an x on the left-hand side, and 5 take away 7 is -2. You can use a number line for this, or you can use your mental math skills, or you could even use a calculator. Example number 6, we'll do, sometimes the letter is not always an x. It could be a b, for example. So let's do b minus 2 is equal to 17. So I want to do the opposite of subtracting 2 to get the variable b by itself. The opposite of subtracting 2 is adding 2. So I'm going to add 2 to both sides. Doing that makes our 0. -2 plus 2 is 0. And we're left with b on the left-hand side. 17 plus 2 is 19. And maybe we'll do a couple of more of the ones involving adding and subtracting, or multiplying and dividing. So example number 7, we'll do 8x is equal to 24. So right now, when there's no sign in between the number and the variable, that's multiplication. The opposite of multiplication is division. So I'm going to divide both sides by 8, because 8 is the coefficient in front of the variable. Doing that provides my 1. So 8 divided by 8 is 1. So we're left with x. And 24 divided by 8 is 3. And the last example, we'll do c over 2 is equal to 12. So right now we're dividing by 2. The opposite of dividing by 2 is multiplying by 2. So I'm going to multiply my left side by 2 and my right side by 2. Doing that creates that fraction, 2 over 2, which is 1. So we're left with c on the left-hand side, and 12 times 2 is 24 on the right-hand side. So work together to solve the logic puzzle, and if you have any questions about this as you're going along, ask your classmates, ask your teacher, and I'll answer some more questions tomorrow when I'm back.